We will wait for 5 minutes, then I will start the class. Let all the students join the classroom, then I will resume. This is the session of 30 minutes. So we were discussing about the single line diagram, or you can say power flow diagram of the induction machine. So up to this point, we have cleared the concept. Is there any problem regarding this power flow diagram of the induction machine? Or you can say the efficiency part. This is the accumulation of the this topic is in the accumulation of the efficiency part. If you don't understand the power flow diagram, you will not understand the efficiency of the induction machine. That's why this topic is important, to understand the efficiency of induction machine. If you have any problem, you can ask me. Power flow diagram, how this input is given, how the output loss, stator loss, then there is a input to the rotor, then there is a rotor copper loss, then there is a mechanical power developed, then mechanical power developed is difference with the start power output that will give you the total output of the machine. Okay, so I think you don't have any problem. Okay, fine. So this is the rotor efficiency. Rotor efficiency is given as the efficiency. Normally efficiency means output upon input. So here it is written rotor efficiency. So the rotor efficiency include the rotor output divided by the rotor input. So from this single line diagram, you can see that up to this point, this is the rotor part. This is the rotor part. So here, this is only the rotor part. This is your P2. Here it is written at P, but in the explanation part, we have taken input of the rotor as P2. So this is your P2. This is the mechanical power developed, and this is your rotor. So this is three part is the accumulation of the rotor part. So a rotor output is your this one mechanical power developed, that is PM, and this is the input of the rotor part. So PM divided by rotor output is PM and rotor input is a P2. So rotor output divided by rotor input, that will give you the rotor efficiency. So that's why it is written rotor efficiency is rotor output divided by rotor input. That is PM divided by P2. Okay, this is the rotor efficiency. Now, if we talk about the total induction motor efficiency, that means motor output divided by motor input, that will give you the total efficiency of the motor. So the efficiency of the motor directly related with the output, that is PO divided by PI. That is what is written here. This is the P out, that is PO. This is the motor output, and this is the motor input. So this accumulation part, total part is given as P output divided by P input. That is the motor efficiency. That is mechanical power. This is the mechanical output. We are dealing with the motor part. So the output will be mechanical power. So that according to the shaft, and the input is your electrical power. Input to the stator. The output to the shaft, input to the stator. That's why this is known as P out divided by P input. So depending upon the different formulas, according to this single line diagram, you can derive the different values of this P out. And this is your PM. PM is the P out plus PML. Okay, in terms of a P output. So P output, you can write PM minus PML. Now PML is the stator loss. This is the stator loss. PML is the friction winding stray load loss. So just you cannot put anything else than PML. You can put the PM, that is the mechanical load power. Mechanical load output, mechanical load power, that is here. You can write P2 minus this one rotor copper loss, or you can say PM here P2 minus PCU. You can put here P2 minus PCU. Now P2 can be put as P input minus PSL. That is P2 can be written as P2 minus PSL. So P2 minus PSL plus PCU minus PML, that will give you the total output of the motor. Okay, when you put different values of PM, then P2, then PSL, then PCU, you will get the PM value, and from that you will get the motor efficiency as well as the rotor efficiency of the induction machine. Now the different formulas regarding this is also given as that the relationship between the rotor input, that is P2, rotor copper loss, PCU, and gross mechanical power, that is total power, that is total rotor power, is given here. The relationship between the input rotor, the loss that occurs in the rotor, and the output of the rotor. This is the rotor input, that is we have dealt with P2. This is the loss of the rotor, that is copper loss. Iron loss is very much small. So that's why that is ignored. And the output is your gross mechanical power, that is mechanical power developed, that is PM. So in terms of torque, this is the power. So the power is given as P equal to TG into omega, as this is the rotation part. Rotor will be rotate. So that's why we have taken omega is your in mechanical synchronous speed. That is given as 2 pi n divided by 60. N is your rotor speed. N is your rotor speed. And TG is your torque in air gap. Okay, TG is your torque in air gap. Okay, so the power in the air gap is given as Tg into 2 pi n divided by 60. Now power transferred from stator to rotor, that means output power of the stator and the input power of the rotor will be equal to P2. As you can see from this diagram, this is taken as P2. So this is the stator part output, and this is the input of the stator part output will become input to the rotor, that is P2. That is what is given here. This is the P2, that is Tg into omega s. Omega is the synchronous speed in the air gap. This is the rotor torque in the air gap, and this is the rotor speed, rotating magnetic field speed, that is given as Tg into 2 pi ns upon 60. Ns is your synchronous speed of the rotating magnetic field. Okay, this is in RPS. rotation per second. This is also in RPS, rotation per second. So this is the mechanical power, that is power in terms of torque, and the electrical power that is transferred from stator part to the rotor part, that is given by this equation, Tg into 2 pi ns divided by 60. Now gross mechanical power developed, what will be the gross power? Gross power means this one. Gross power is this one, mechanical power developed. What will be the value of mechanical power? That will be also given as Tg into omega. Tg into omega, that is given as this one, 2 pi Tg into 2 pi n upon 60. That is what given as power equal to torque into speed. As you already know, this is power and torque is this term is very much important and relatable for all the mechanical and civil students, because all the fourth year up to fourth year you have to deal with this power, torque, omega, speed, all these things are very much correlatable for your civil as well as mechanical students. So all of you must understood this terms of torque and power transfer, mechanical power. This is the gross mechanical power that developed. That is, power is given by torque into speed. This torque is taken as Tg. Tg air gap torque, or the electrical torque that is developed in the rotor part, and omega is the speed with which the rotor is rotating. Okay, omega is the speed with which the rotor is rotating. So omega value is given as 2 pi n divided by 60 in RPS, rotation per second. If you want to write this term in RPM, the rotation per minute, then you can ignore this 60 value. Just write 2 pi n. That will give you the mechanical power developed by the rotor. Okay. Now the rotor copper loss, as you already know, this is the rotor copper loss, PC equal to P2 minus mechanical power developed. You can see here. This is the input part P2 and this is the mechanical power developed. As you know, because of this loss, the mechanical power developed will have the less value than that of the input. So the rotor copper loss, you can write P2 minus PM. Okay. So from here you can see that this is written as P2 minus PM. Just put the value of P2 and PM. P2 have the value Tg into 2 pi ns upon 60, and PM is given at Tg into 2 pi n upon 60. So okay. So from these two equations you will get Tg upon 2 pi 60 as the common term, and bracket within the bracket ns minus n, that will give you the relative speed between the rotor and magnetic field. When you divide this term with ns, you will get the slip. When you divide this whole term by ns, that means you will get the value of the slip. So this is all about the rotor copper loss. In the next term, there is a relationship between rotor input, rotor copper loss, gross mechanical power is also given as here. So here you can say that PC copper loss, when you divide by P2, you will get this term. When you divide this P2, just put the value of PCU that we have derived. Here you can say PCU value derived. Just put the value of PCU in the upper part and divide with the rotor input part. That is this value. TG will be cancelled. 2 pi upon 60, 2 pi upon 60 will be cancelled. NS minus N divided by NS will be there. So that will be equal to NS. That is copper loss equal to slip into rotor input. That is, this formula can also be written as copper loss equal to slip into input rotor input. So from here you can write rotor input equal to copper loss divided by your slip. That will also give the value of rotor input. But from the previous equation, this is mechanical power developed. Mechanical power developed is the rotor output part. So there is the copper loss and there is the input part. So input minus loss, copper loss, that will give you the mechanical power. So from here, you can write as PCU. This is PCU equal to slip into your input power, input rotor. So just put the value of PCU as S into P2. The S into P2, you will get P2 equal to 1 upon S. 1 upon S, and your copper loss divided by mechanical power developed. When you divide these two terms, you will get SP2, PC equal to SP2 from here. PM mechanical power developed equal to P2 into 1 minus S. From here, you will get S upon 1 upon S. Now, from here, you will get P2 equal to, as we know, P2 equal to TG. These are some formulas that you should consider. You don't have to very much dependent on this formula, because very less numericals will be asked from this induction machine. Okay, P2 equal to Tg into 2 pi ns upon 60 as already discussed. P equal to P2 equal to Tg into 2 pi Tg equal to 2 pi ns upon 60. So from here P2 equal to Tg into 2 pi ns upon 60. Now from here that air torque in synchronous what is given as P2 into 60 divided by 2 pi ns. Okay, so Tg is directly proportional to P2 as 60 2 pi ns. All these things are constant. So that's why it is written as Tg is directly proportional to P2. Torque in synchronous watt is given as P2, that is PCU. Okay, PCU upon that is torque. Torque is given as P2 equal to. So as Tg is directly proportional to P2, that's why it is written as torque in synchronous watt equal to P2, and that is relatable with PCU copper loss divided by slip. And that slip is also, you can write copper loss is related with your mechanical power developed related with slip in this format. PCU upon S from here, and from here you will get PC equal to PMS upon 1 upon S. Okay, so accordingly the formula is set up. Now this is the numerical term. So this is all about the efficiency of the induction machine. Acha, let me show you one thing. The percentage of losses that occurs in the induction machine. So from here you can see that. From here you can see that there are two types of losses were there: constant or fixed loss and variable losses. The percentage of losses that occurs. This is the input part. This is the output part. So there many losses was there. The first loss was is stator loss. Stator loss is the maximum percentage. The stator loss has copper loss as well as your core loss. So both are losses are accompanied. That's why it is given as your. That's why it is given as your 40%. Then there is a rotor loss. As the in the rotor loss, there are two types of losses was there: copper loss as well as the iron loss. Iron loss being very small value, those are neglected. So only the left one is your copper loss. So the percentage of rotor loss is your 25%. Then there is a core loss, or you can say iron loss. Iron loss is approximately equal to the rotor loss. That is 20%. Then there is a friction and windage loss. The value of the friction and windage loss is about 5%. So out of these losses, this is the very much small value. Now the additional, or you can say miscellaneous losses, that is accumulated of leakage loss, or you can say stray load loss. So those losses are accumulation carries to 10%. So in this format, the total output is given. Okay, that means if you give a P input as your 200 watt, you have given 200 watt, you will get, let us say, 150 watt. 50 watt will be given out in terms of your losses. Okay, maximum losses will go in the stator part, then accordingly the rotor part, then iron loss, then friction windage loss, and then the additional losses will be there. Okay, so depending upon the type of machine, the efficiency cannot be your 100%, because of in 100% will be there for the ideal case, but for the your practical case, the efficiency will not be your 100%. There will be some losses always there in the machine losses. So for the condition of maximum, so this is the variable loss that we have discussed. So for the condition of maximum efficiency, this variable loss must be, as you can say, efficiency of three phase output upon input, rotor output upon rotor input, that we have discussed, all these things that we have discussed. So the condition of maximum efficiency will be when these two losses, or constant loss and variable loss, become equal. There is constant loss or fixed loss when become equal to the your variable loss, then only the condition, in that case the machine is said to be working as a maximum, working at maximum efficiency. Okay, so all of you must take the screenshot of the topic that I have taught. So I am again showing the presentation, or you can say PPT. So all of you must take the screenshot of this topic, losses and efficiency of the induction machine, so that in the further cases you should not worry about this loss. Okay, you can take this screenshot. This one also, जो जो स्लाइड हम शो कर रहे हैं सबका स्क्रीनशॉट ले लीजिए आप लोग. main thing is to understand this PPT, okay, power flow diagram. If you understand this concept, whole concept, you will easily solve the numerical based on this losses and efficiency. So we have done the, let me go through the syllabus. So mainly losses, components, and efficiency is completed. So we have completed two topics today's. These two topics already completed. In the next class, we will deal with this topic. The last topic that is related with three-phase induction motor. That is a starting and speed control of induction motor. How can we control the speed of induction motor to operate in different conditions? Okay, there are sometimes we need a high starting torque, a high speed for the application, for different types of application. But in some cases, we need to control the speed of the induction motor to work to perform a work. So there is a need of speed control in induction motor. So that we will discuss in the next class. Okay, so if you have any problem, you can ask me. So further, let us discuss a numerical based on the induction machine. Start efficiency, sleep. Okay, so here you can see that a 6-pole, you can say this is the number of poles given, 6-pole 3-phase induction motor develops a power of 22.38 kilowatt. It is developed power, that is power developed, including mechanical losses, which total 1.492 kilowatt. This is the loss. This is the loss, mechanical loss, that is 1.492 kilowatt at a speed of 950 rpm. 950 rpm पे on 550 volt. On 550 volts. Wait a second. So this is the 950 rpm on uh, 550 volts. This is your line voltage. The voltage that is given in the numerical, you must take is a line voltage. If it is phase voltage, it will be given in the question. If it is not given, then you should treat as a line voltage. Okay. This is the supply frequency, that is 50 hertz. The power factor is 0.88. That is cos theta. That is 0.88 calculated for this load. Sleep. Now we have to find the value of sleep. As sleep has the value ns minus n divided by ns. So for the value of rotor speed, you can say this is the 950 rpm. This is the rotor speed. And for the sleep value, we have to find the rotor synchronous speed. And for the synchronous speed, the value formula is 120 f upon p. F is given as 50 hertz. P is your number of poles. 6 is given. So 120 into 50 divided by 6. That will give you the 1000 rpm and the rotor speed 1950. So when you put the value of ns and n, you will get the sleep as your 0.05. Okay. So this is the value of the sleep. Second one is your Second is rotor copper loss. Rotor copper loss, that is 3 I2 square R2. 3 I2 square R2. Okay. rotor copper loss in terms of I2 square R2, or you can say this rotor copper loss, you can write it as slip and mechanical power developed. Okay, mechanical power developed. From the mechanical power developed, you will get this P2 bracket, within the bracket 1 minus S. You have the value of S, you have the value of mechanical power developed. You can see that mechanical power developed it is given as 22.38. 22.38 is given as kilowatt. So from that 22.38 is mechanical power developed. Sleep have the value 0.05. Just put the value, you will get mechanical rotor input. Rotor input, from there you will get the copper loss. Rotor copper loss related with input. Rotor input is S into P2. That will give you the value of 0.05. That from there you will get 1.17 kilowatt. Now the total input is given by this. Total input is given by P input. Okay, that is P input is the input. P total input is the stator losses plus the output of the stator. That will give you the input power. So the P2 is you are given as 23.55. You can see that this is your P2. You have derived, found the value 23.2. Stator loss is already given as the 2. Mechanical loss is 1.492. When you find that, the slip will be become 2. Okay, that from there you will get 25.55 kilowatt. Okay, the efficiency P output equal to P minus, according to this formula, these are correlated with each other. Just relate the formulas and put the value, you will get the different types of component of the induction motor. So this is all about today's class. We will discuss the next topic in our Saturday's class, because tomorrow there is no class of ESC 101. So all of you must give your attendance, and thank you for the session. Thank you for attending the class. You can leave. If you have any problem, we will discuss in the next class, because the battery is very much low in my mobile right now. So you can leave now. I'm ending this session.